First, we have to read the question. I think that's an important skill because the question will tell you half the answer. For example, here it says that C is measured in degrees Celsius. The answer to everything that follows would have been very different if they said C is measured in degrees Celsius per minute. Okay, so please pay attention to what the C is. Okay. Now, it says here, approximate C prime of 5 using the average rate of change. Now, my question to you is, if you want to approximate the C prime of 5, which points of time would you pick?
Do I pick the C of time of like 3 and 7?
Exactly. So you're going to do C of 7 minus C of 3 over 7 minus 3. And we're going to say C prime of 5. Since they said approximate, you must put the approximation sign only in the beginning. Yeah. So then just put equal sign. And instead of C of 7, we'll put 69. And instead of the C of 3, we'll put 85 over 4. Now, of course, the first two questions are allowed a calculator. That means you must pull up the calculator and check what is going on. So I got myself right now -4 degrees Celsius per minute because you simply divided it by minute. Show the work that leads to your answer, which we did, and also includes units of measurement, which we also did. So right now we took care of part A, correct?
Yeah.
Okay, let's move on to part B. Now, use a left Riemann sum with 3 subintervals to approximate the value of 0 to 12, the integral from 0 to 12. Now, so this is going to be our data. And they're saying using left Riemann sum. That means you must ignore the rightmost CT.
So we're going to take C3, 3, 7, and 7, 12?
Yeah. So look, they said approximate. Where is it? They said approximate. That means you will do integral from 0 to 12 CT dt is approximately. You do 3 minus 0 times 100. Plus 7 minus 3 times 85. Plus 12 minus 7 times 69. Please get us the answer so we can move on with our lives.
I got 985.
985. Very good. And they're saying interpret the meaning of this. This formula reminds me of the MVTI. Do you know what that is? If you don't, that's okay. 1 over b minus a from a to b fx dx.
Isn't that the average change?
No, it's the average value. It's the average value. Okay. So we're going to say, how do you interpret this one? You're going to say the average value of temperature in the coffee cup is 985 degrees Celsius from T of 0 to T of 12 minutes. Okay, let's move on to part C. So from 12 to 20, which if you notice is not on the table, the rate of change of temperature is C prime given by this equation. Okay, and find the temperature of the coffee at the time of 20. Okay, and show the setup to do that. So how would you find that? If you're given rate and you're asked to find the you're asked to find the temperature, that means you have to go from degrees Celsius per minute to only minute. So how would you, to only Celsius. How would you get rid of that minute? No, you actually have to integrate. You have to integrate.
So you then do from 12 to 20?
Yes, but are we given the C of 12?
C of 12?
Because you have to start at 12. So like you must say C of 12 plus the integral from 12 to 20 and the equation C prime t dt, and you will get the answer. If you go back to the table, when the time was 12, the C was 55. That has to go on your answer. 55 plus the integral in the calculator from 12 to 20 C prime t dt. And we can use Desmos for that. Alright, so look, I'm gonna go ahead and I'm gonna put it in Desmos. So 55 plus, go to function, integral from 12 to 20, and the function is going to be, you have to write it down, so it's going to be negative 24.55 divided by, and t or x will go on the bottom, and then on top we'll put the rest, which is e, which is here, to the power of 0.01x. Now, of course, right now there is no number showing. Why? Because I must now put dx. Okay, so now I'm going to write dx. And now I have my number, which is 40.329.
I did put 55 plus.
So 329. Okay. That was easy. Now part D, for the model defined in part C, it can be shown that C double prime is equal to this. And they're saying now, determine whether the temperature is changing at a decreasing rate or changing at an increasing rate. Okay, so let me tell you what's going on here. Do you know what it means to say changing at decreasing rate or changing at increasing rate? Okay, so if they're saying changing at decreasing rate, that means that the C double prime is negative. And if they say changing at an increasing rate, that means your C double prime is positive. So what I would do right now if I were you, I would actually go to Desmos or a graphing calculator and I would graph this one and make sure my window is from 12 to 20, and I would see if it's above the x-axis of the graph or below the x-axis. If it's below the x-axis, it's less than 0. If it's above the x-axis, it's more than 0. Let's go to Desmos. Alright, moving on. Nice conversation with you. So 0.2455 e to the power of 0.01x. And now divide and put x squared in the bottom and go back to the numerator and put a bracket 100 minus x. Now, like we said, make your window from 12 to 20. So go to the spanner here and make your x ranging from 12 to 20. And now, as you can see, my figure is a bit weird because my y is way too large. So go here again and make your y smaller. Like let's say make it -1 to maybe a 1 and c. Or maybe make it, where is it? -2. Yeah, 2 would be perfect. See? Now, what do I see in here? Is my graph above the x-axis or below the x-axis? Above. That means it's increasing. Or changing at an increasing rate, basically. So we're going to say that since c double prime of t is more than 0 for 12 to t to 20, it means the temperature of coffee is changing at an increasing rate. We good? Any questions? The particle moves along the x-axis so that its velocity at time of t is given by this. There is one time in the interval when the particle is at rest, which means not moving. Okay, so find the TR, so find the time when the particle is not moving. If the particle is not moving, does it have any velocity? No. So right now let's go to your graphing calculator or Desmos and just plug this in, plug this equation, and then see where it hits the x-axis basically. So we're gonna have ln, so go to functions and look for ln. X squared minus 4x plus 5, close the bracket, minus 0.2x. Okay, my window has to be from 0 to 2. So from 0, it's like window, yeah. Window is window.
So it's not graphing anything. It's not graphing anything. It's a very bad time to like draw.
We could probably Google it, but I'll reset it if I were you. Alright, so it's going to be hitting the x-axis at this point, which is 1.425. That's when the velocity becomes 0. So TR is equal to 1.425, essentially. Okay. That's when the particle, becomes at rest or simply not moving. Now, for a time that's less than TR, but more than 0, so for a time that is more than 0 but less than 1.425, is the particle moving to the right or is the particle moving to the left? Okay, so let me tell you something. You're going to look back at your velocity graph. If your velocity is more than 0, that means above the x-axis, that would mean it's moving to the right. And if your velocity is below the x-axis, that will mean moving to the left. Okay, so let's go back and see it. Our window has to range from 0 to 1.425. So make this banner from 0 to 1.425. You see it's above the x-axis. That means what? That means moving to the right. So we're going to say the VT is more than 0 for t bigger than 0, less than 1.425. So the particle is moving to the right. Okay, that was all part A. Part B, find the acceleration of the particle at time t. How do we get acceleration if we're given the velocity equation? No, prime. So acceleration is the prime of the velocity. d over dx of vx. Okay? At x of 1.5 or the time of 1.5. So how would we go about doing this in Desmos? Let me show you. Desmos is provided, but it's going to take up half of your screen. It's going to be hard to use. Okay? Alright, so what do? We're going to come here. We're going to basically do functions, and we're going to go to d over dx for derivative. And we're going to just simply copy what we already said before. So copy the equation of velocity. Ln, so x squared minus 4x plus 5, close the bracket, minus 0.2x. And right now we're looking for the acceleration at the time of 1.5, if you recall. So I'm going to go ahead and click on this settings, click on the table, and write 1.5. And my acceleration is equal to a -1. No, it's -1. So when time is 1.5, our acceleration is going to be -1. So come back here and write that the a of 1.5 is equal to v prime of 1.5, which equals to -1. Okay, so far so good. Now, what they're saying is the speed of the particle increasing or decreasing at the time of 1.5? Let me show you what that means. So look, how do we know if the speed is increasing at time of 1.5? And how do we know if the speed is decreasing at the time of 1.5? So if the velocity at 1.5 has a sign and the acceleration at 1.5 has the same sign, so they're either both positive or both negative, it's increasing. But if the acceleration and the velocity at 1.5 have different signs, so one is positive and one is negative, the speed is decreasing. So now what's our job? We already know that the acceleration at 1.5 is -1. But now we have to go back to the Desmos and find out the sign of the velocity at 1.5. So back to Desmos, go to your velocity equation and click on the setting bar and look for table and write 1.5. Our velocity is what? Our velocity is -0.076. So now we're going to say that the acceleration at 1.5 is -1, and the velocity at 1.5 is -0.076. So since they are the same sign, the object is increasing in speed. Okay, the object is what? Increasing in speed. Okay, C, the position of the particle at time of t is x, and the position of the particle at time of t1 is equal to -3. Find the position of the particle at the time of 4. Okay. Okay, now, so for the part C, we're going to say x of 1, you must always write the initial position, plus integration from 1 to 4. You must integrate the velocity. And x of 1 is how much? It's given to us as -3 plus the integral of the velocity. So now, please go to Desmos or your graphing calculator and do the math. So here I will do...
From where? The boundaries.
From 1 to 4.
1 to 4.
So I'll do -3.
I got -0.59.
Okay, function integral from 1 to 4. And now just put your velocity equation. So put a bracket. Yeah, now it's right. Now it's right, thank you. How would you get it wrong the first time?
I didn't put plus. I don't know, I think I did disappear.
Interesting. And of course, right now there is no answer because I did not put dx yet.
Yeah.
So I put dx and now I got -2.802. So I got myself -2.802. D. Find total distance traveled by the particle over the interval. Do you know how to find total distance?
Of course.
How?
The absolute value of the velocity.
Smart. Absolute value of the velocity. Integration, of course, from 1 to 4. Yes. Let's use Desmos. So here, I'll remove this guy.
So
put absolute value before the dx. So I got 0.958. So 0.958.
Got 0.958.
Yep, that's correct. Okay, so here when they're asking us to sketch the solution curve through the point 0.04, just go with the flow of the slope field. Okay, you just got 1 point. And here they're telling us that you want to find where h has a critical point. H has a critical point when the dh over dt is equal to a 0. Okay, now if you look back here, okay, you should know from the unit circle that when the x is pi over 2 or 3 pi over 2, then the cosine of these two is going to be a 0. So the cosine of pi over 2 is a 0, and the cosine of 3 pi over 2 is also going to be a 0. So right now, if I pick my time to be pi, my cosine of pi over 2 will be a 0. And if I pick my time to be 3 pi, my cosine of 3 pi over 2 will be 0. But here's the catch. We cannot use time of 3 pi because that would be more than 5. We're allowed to be maximum 5, right? Or less than 5, I mean. And 3 pi is like a 9. So stick with the pi, which is like a 3.14. It's within the range from 0 to a 5. So now we know that we have a critical point at the time of pi. Okay. Now, the question is this a maximum, a minimum, or neither? So that means we should assess the dh over dt on the left. We should also assess the dh over dt on the right of this point. And here is where the slope field comes into play. So obviously we can tell that it is 0 at 3.14, which is pi. Look at the slope field. Is that positive or negative on the left? Thank you. And how about the right? That is a maximum. Is that method good?
Yeah.
So dh over dt is more than 0 for 0 to 2 to a pi, but dh over dt is less than 0 for pi to a t to a 5. So a t of pi is a relative maximum.
I mean, that better than the first method.
I know. Now, using separation of variables, that means you actually have to integrate. Okay. So do you know how to go about doing this one?
You just do like the integral.
Wow. Okay, that made it very simple. So we're gonna do dh over h minus 1 is equal to half cosine of t over 2 dt. Okay. Now, how would you integrate h minus 1? That will be ln, correct?
Yeah, like h minus 1.
So you're going to do ln of the absolute value of h minus 1, okay, is equal to, oh, you must not put this integration sign, is equal to half. What's the integral of cosine? Sine of t over 2 divided by the derivative of t over 2, which is half. Okay. They cancel, yeah, because the 2 on the bottom with the half will simply cancel. Sure. Yeah, we're good. They will cancel. Okay, plus c, of course. Now, the question is, what is our h? Our h is 4. So 4 minus 1 is a 3. Because your answer is positive on the inside, make the absolute value into just brackets. And now start to replace. So now I'm going to say ln of 3 is equal to sine of t over 2. And instead of time, you put 0. So sine of 0 is how much? Sine of 0 is 0. So only c will remain. Now go back to your equation. So you're going to say ln of h minus 1 is equal to sine of t over 2 plus ln of 3. How would I get rid of that ln? I must use e to both sides. So I'm going to have h minus 1 is equal to 3e sine of t over 2. So that means h is equal to 3e sine t over 2 plus 1. That's the equation basically. Yeah, we got it. Okay, so find the value of g of minus 6. So we're going to do g of minus 6 is equal to integration from 0 to minus 6 ft dt. If you will integrate from 0 to minus 6, that means you actually have to go backwards. Yes? And if you go backward, that means you have to use a minus sign when you integrate. So minus the r. And r is already given as 12. So what's the answer going to be? Just minus 12. Yeah, that's for the g of negative 6. Now, for the g of 4, that means you have to do from 0 to 4 ft dt. That means you have to go to the right. So no need for the minus sign. That's essentially, is that a triangle basically? So we're going to do half by base by height, which is 4. And now for the g of a 6, we have to do from 0 to 6 f of t dt. That means we have to basically 0 to 6. Thank you. That was marvelous. So what do we have right now? We have a triangle above the x-axis. We have a triangle that's below the x-axis. Yep, so we're going to do half by base by height minus half by base by height. So we're going to do 4 minus 1, which is 3. Very good. Easy. Now, part B says, for the function g defined in part A, find the values on the x at which the graph of g has a critical point. Now, look, to assess critical points, you must take g and you must actually differentiate it. So you're going to say g prime of x is equal to, when you differentiate the integral goes away, right? F of x. And of course, the critical point means you have a 0 at these points, right? So find out where the g prime is 0, which means where the fx hits a 0. So where does the fx hit a 0? Where does the graph hit the x-axis basically? At 4. Exactly. So at x is equal to 4. How easy is that?
That's it?
Yep. I know. Now, part C. Part C says the function hx is defined. Okay, so look. If they want h of 6, that means you have to do from negative 6 to 6 f prime t dt. Now, you cannot go back to the graph and find the areas. Do you know why? Because the graph is for the f. Right now, we're integrating the f prime, so it's a different thing. So what do? What happens when you integrate f prime? You get f. So you're going to get f of 6 minus f of negative 6. Now go back to the graph and find out what f of 6 f of 6 is negative 1. And what's f of negative 6? 0.5. So minus 1.5. That's h of 6. H prime of 6, that means you have to differentiate both sides. When you differentiate an integral, the integral simply disappears. So you're going to have f prime of 6. Now you should go back to your graph. And let's just clear this up. Well, we have to find the f prime of 6. Yani we have, and 6 is here. So that means we have to find this slope of this line. So we're going to pick this point, which is 0, 2, and this point, which is 4 and 0. Slope is equal to 0 minus 2, 4 minus 0, so minus 2 over 4, which is negative half. So the slope is going to be negative half. And now they want the edge double prime of 6. And so that means you have to differentiate the negative half, which becomes 0. When you differentiate the number, it becomes a 0 only, right?